Okay, here's the 12 volt control power right there. There's the power 12 volt power for the power section. It's got a little fuse and then the contactor. Now, here is B minus, B plus, and then M plus. Then it goes M plus goes over here to this inductor, 300 microhenry inductor over to some resistance wire in some water, and it's like 0.17 ohms, something like that. And then connects to M minus there. There's the current sensor on M minus, and then B minus bar is right there. This first test is going to be from on the oscilloscope is going to measure from M plus to B minus. So B minus is where the ground is hooked up on the oscilloscope. And I'll give it just a little bit of throttle. Let's see now, maybe 4 or 5 amps, just enough so we can see what's going on. Whoops. How about 5.8 amps? Okay. Now we look over here, and we have this. So this is at 100 nanoseconds. 50, here's a 20 nanoseconds. So like the period is about, what's that, 20, 40, maybe 30 nanosecond period. Now let's slow this thing down, kind of see what it looks like. There we go. Alright, so there's that ringing. Also notice right there, it's kind of weird. There. So M plus to B minus. Okay, just a little. See, lower throttle. That goes down. Increase throttle. And it goes up. So right here, for example, is 7.5 amps. And here, whoops, that's 0. Something like that would be 2 amps. So we're probing from B plus to M plus now, drain to source on the high side MOSFETs there. And we're at 0 amps. This is at 50 nanoseconds per division. So 0 amps. Come on. 3 amps about. 4 amps. 6 amps. 7 amps. 9 amps, 10 amps, 13 amps, 14 amps, 16 amps, 7, 5, 4, 3, 2, 1, 0. And that those spikes down there were from turn on, MOSFET turn on. Now we're monitoring from MOSFET gate to MOSFET source on, so basically the high side MOSFET. It's 0 amps right now. Let's get this thing going here. There's 2.4. Oops, let's turn this down a little bit. There we go. Okay, now let's speed this thing up a little. Let's increase this resolution a little bit. Other way. There we go. Position down. So this is at 2.7 amps. This is MOSFET turning on. 200 nanoseconds per division. So this is at 2 amps. Start over. Here's 0.7 amps. 1 amp, 2 amps, 3 amps, 4. Speed it up a little bit. 4, 5, 6, 8, 9, 10, 11. 12, 13, 14. This coincides with the noise on the diode and also on the MOSFET that I was looking at, by the way. Turn it down a little bit. 9 amps. Now let's zoom out a little bit to see where we are voltage-wise. So the voltage swing is around 2, 4, 6, 8, 10, 12, 14. A little over 14 volts for the turn on. And the spike is going up to about close to 11, a little over 11. And we turn it back down to, ooh, and then off, and it goes up, off. Well, that was interesting. And then up. So as the current changes, that one little spot right in the middle there just keeps going up, doing that. That's at 12.5 amps right there. And you turn it down and it's 0.4 amps. Okay. Here's how it looks with the power section turned off. I mean, you know, no 12 volt power to the power section. So it's like that, 500 nanoseconds. Still that little. This is the area where the noise was. There's still a little tiny wiggle right there. And I don't know what that's all about.